States. There you go. 8.1 Sweden. It's the high. Okay, good. And then I have to shorten this up.
Yeah.
All
Well,
right.
so it needs to find the average. So at this point in time, you haven't actually found the average.
I thought the average
of the remaining 5. Yeah, you haven't found that yet.
Oh, I thought this is the average. This is not the average here.
No, that is an average. It's an average of whatever the middle 5 judges are. So it's
Right.
taking. So let's go back. Let's go back and look at your code. Let's see what the average is getting. So
the average.
Yeah. So it says the sum of score 5. Well, what's score 5?
Up here, right here.
Right. And so that's the Olympic judges from 1
to 5.
From 1 to 5. So that means that's getting France, Germany, Britain, Great Britain, Sweden, and the United States. Is that necessarily the correct things it's supposed to get?
That's what I thought. That's what I thought the homework was. I thought it was the homework that we're supposed to get the 5 middle judges.
So, okay, I see you're saying that. I see your understanding. So it's the 5 middle scores. So if you put the scores in order for the, that makes a lot of sense why you would think that. No, and I apologize to anyone that got that from it. So it was the 5 middle scores. So if you put the scores in order from least to greatest.
So we got to sort it. We got to sort the scores and then take the 5 middle out. Okay, I see.
There you go.
All right. I forgot what the command is for sort, but I'm assuming it's just sort and the function. But let me see. Go back here.
Yes, you are correct. It's just a list and then dot sort. That's all.
Okay.
But you want to be careful where you do it. I'm just gonna let you know now.
Yeah, no. Okay, I got to do it after the scores are entered. So I got to put it. Let me think. See, I got the list of scores. I can put it right after here, right after this one.
So if you put it right after that, the order in which actually go ahead and do it so you can see what happens.
You tell me I shouldn't put it there. Okay, let's see.
Yeah, I gotta stop myself from doing that. You guys gotta be able to see some of this stuff or like play with it and see what happens. That's what I do in real life. Yeah.
So I can say sort and function.
You give it the list first. You give it the list first, and then you put a period.
OLYML period sort.
And then it's just open close parentheses, and that's it.
That's it?
Yep, that's it. And then it'll automatically sort it. It'll sort Olympic L. Yep.
Okay. Oops, wait a minute. I kind of control F and F5. Okay, so we got 7.7, 7.5, 7.9, 7.8, 8.1, 7.4, and 7.6. Okay. Didn't do anything, did it?
Look what happened there. So the low score, it now says it's 7. It got the same low score, right? But notice it says for China, although China didn't enter in 7.4. Notice it says that the high score is 8.1 for Zimbabwe.
Oh, I already put it in the wrong order. Yeah, I changed something in there. Let's see. What did I change?
Think about what did you just change? There's only one thing you changed just now. What was it?
I told it to sort before it actually finished calculating.
Yes.
Yeah.
So where should that line go instead?
Let's see. Oops. Cut this out of here. Edit. Cut. Okay. Delete that. So that should be. After first should be down here.
Mm-hmm.
Let me take this out. Put that up, and I'll just put it. Control V. See, because the average. Wait a minute, let me think about this. Because it's going to do. Well, the average is not going to change. Let's see. So right there. Let's try that. Okay.
Okay. So I was going to because
go back. Okay.
Yeah. Okay. So, but this because yes, one thing to note is that if you put it after that, it will still be sorted. But you haven't made any changes to what you're doing to find the average yet. So That's
Oh
for the
yeah.
second.
Oh yeah. Oh, that's
So
right. You're right.
so
I got to
so but
go ahead. So I got to change the average. So we're averaging the scores. Okay. So yeah, we're averaging the scores. So average some.
when do you want to average the scores?
Right before the. Let me see. Right before or after the sort. Let's see. We're averaging the scores first. I mean, we're sorting out. Oh, I see. It's this is what the has to go here. Control C. I mean, let's edit. Edit. Let's cut down. Put this right here. Right there. In that order.
Yes.
And then, but this is wrong. This is wrong.
Yes. Yes. So hold on 1 second now. So everyone, I want you to take a second to think about what he just said. So he said that I needed to sort. The average should happen before or after. He asked himself that question: when should the average happen? Should it happen before he sorts or after? And then he said, well, what is the average? We're taking the average of the middle scores. Well, the only way he can know what those middle scores are is if it's sorted first. So that's how he decided that the sort goes before he takes the average.
Right.
Okay. All right. Good. So
that makes sense.
So let's see. How are you taking this average? Well, your average uses the list score sum. Where's that at? Score 5. Sorry. Where's
score
it
5?
at?
Score 5 is at the beginning up here.
Right.
Score. Okay. So I got to do that after you sort it. I have to take out here, and I got to edit, cut this out, and I got to do it here first. Control V. Okay. If I do that, and this is 5 out of 7 scores. Okay. Mm-hmm. Okay. So it'll take the score. Give me the 5. It'll sort it out. Then on those 5. Then I average those 5. And then that's it. Yeah, that should be it.
Okay. So the only other thing I want to ask you about, or just point out, is there's going to be something that will cause you an error. And just for the sake of time, I don't want you to have to go through it. And the only thing is at the beginning of when you're starting to do these calculations, you have that min score 5. All right.
Oh yeah, minimum score of 5. Okay, yeah.
Yeah. Are you using that at all?
No, I don't. You see, am I using that? Let's see. No, I don't think I have to. I don't think I have to because no, I don't think I have to because why did I put that there? Middle school. Oh, I think I did because I wanted to see it. I think that's why I did. So let me see. Shift here. We'll just comment that out. Okay. Yeah. Okay. All right. Let's run this. See what I did. Control S5. Okay. Oh, wait a minute. Let me do it this way because it's messing up. Let's do it. Do you want to save it? No. Do it again. Control S5. Okay. There we go. Now, what you got? Can you read again? 7.7.
7.7. 7.7, and then 7.5.
Okay. What is it?
Oh, sorry. 7.5. And then 7.9. 7.8. 8.1. 7.4. And then 7.6. There you go.
Okay.
So now you just need to so everything is looking correct. The only thing is, like you mentioned earlier, about the formatting for average score, because it's supposed to go to 2 decimals, but that's it. So everything else is good. Okay. You have everything taken care of. You just gotta do that. Okay,
so formatting will be average is, what is it, .2f? Dot 3f. Dot 3f, right? Dot 3.
I think it says 2 decimals.
Oh, 2 decimals?
So to do that, you need to put a colon after the word average, or after AVG. You put a colon.
Okay.
Yep. Okay. And then after the colon, we'll tell it what the format is. So you're saying you need to format it 2 decimal places. Yep. That's it.
That's good. Control S. F5. Okay, I just want to make sure it's right. I got to resubmit this thing. That's good. 7.
Good. No. While he's doing that, you don't have any questions about anything that we just did, or about how he decided to do certain things?
1.4, 1.6. There you go. All right. Okay, that's a good deal. Okay, so I just had my arrays in order. I had to have it redo. Okay.
Yeah, and so and all of this was about the order in which you did things. Again, this is not the only way to do this. I mentioned you didn't have to use lists in this at all. And if you actually do this, but this works out. Like he said, for him, when he was trying to do it nested conditionals, and then he said it just made more sense in the list, and so he went straight to just putting it in the list. But he made it his own code. The suggestion was to use the nested, so that way you have practice with it, and because that's really the level that this question is at. You can take some of the other things that we've talked about though and use it, like just like Rodney showed here. But it's completely up to you and what you want to do. So, but the idea was always the same. You are looking for the lowest score. If you're not sure what it is at the beginning, then just set it to the first thing that's given. First time someone enters something, so first time someone enters 7.7 in China is there. All you got to do is say, okay, low score is 7.7. The low country right now is China. Next it goes and someone enters in France. Okay. Then I say, hey, is the value they just gave me, is it less than 7.7? If it is, this is my new minimum. If it's greater than it, then this is my new max. And then keep moving through each one. After you do that, you will have the list of values that are the lowest and the highest. It will be there automatically. So yeah, that's all you can do. Yeah. So something else to think of is, how do you determine an average? And I'll start. I'm gonna share my screen. Thank you for that, Ani.
Yeah. Okay. Great. Thank you. Appreciate it.
Yeah.
Okay.
No
I'll just resubmit it.
Yeah. You're good. Yeah.
Okay. Let's cancel this. How do I turn this polling thing off? Just hit it. Okay. There you go. Okay. So would I unshare or something? How do I get out?
Oh, I already took it away from you. Yeah.
Oh,
You can
okay.
just
Good.
yeah. You're good. You can just mute. Yeah. That's it. So I gave you guys some like pseudocode. And what pseudocode is like, it means, oh, this is kind of code. But this is how you can think about things. So I usually go to pseudocode after I have planned. Sometimes pseudocode will appear in my planning. Lately, I've tried to stay away from doing that because of certain things that I've been doing, certain projects for my own personal homework. And I've just noticed how if I start doing pseudocode in my plan, usually for myself, what ends up happening is I'm coding. And remember, you don't want to code until after you've actually planned things out. There have been so many times where I've like, man, I just wasted 3 hours because I was trying so hard to do the code that I wanted to do instead of planning it. And then it took me 20 minutes to do this assignment. So, and this, I'm being that serious. This is the reason I say it stresses to you all, because it is very important to plan out what you want to do first before you just jump in and do it, because it's a real thing. And I have to tell myself that too. Like sometimes I catch myself too late doing it. Other times, like I get it at the beginning, and it's like, oh man, that was a fun thing to code. But it is really important to actually plan out what you want to do, and then if you want to do some pseudocode before you move the code, that works too. So anyway, but this was here to give you an idea of what to do, and break it up into chunks. See how, like for instance, Ronnie decided he was doing a list. So when he decided, I'm going to do this as a list because I'm having trouble understanding the nested conditionals to do these, or it seems like it's too much. Okay, so what did he do? He said, well, I need to get the information from the user. So he knew how to do that, but then he changed it and said, you know what? That's the same every single time. So instead of me asking the user 7 questions, I'm gonna ask the user 7 questions, but I'm putting in a loop. So that way the loop will do that for me. Okay, instead of him having to hard code it. So that was modifying what he wanted to do. He knew what he wanted to do, asked the user 7 times, but he recognized that if I'm repeating something multiple times, that means I should do a loop. So he made a change here. Again, was not necessary, but that's a great of the things that you all have learned at this point in time and how to implement them together. So, but from the pseudocode, you can just start from the straight off. You ask them for China score, that means you are automatically setting that you could set the lowest country and the highest country to be China, and set the score to be the same for you set the low score and the high score to China. What happen if you did that? Well, the next score that comes in is France. Let me just actually show an example for this. Next score that comes in is France, 7.5. Well, is 7.5 going to be less than 7.7? Oh, it is. So maybe France is now the new low country, and this is my new low score. Well, that's still the max one, right? Because I haven't made a change to that. I can check to see if this is also greater than that. It's only going to be one or the other, right? It's either going to be greater than or less than or equal to. If it's equal to, we don't even care. If it's less than, then this should be the lower one. If it's greater than, this should be the max one. We'll go to the next one. 7.9. Is 7.9 less than the excuse me, is 7.9 less than the low country score? Oh, it's not? Okay. Is it greater than the max country score? Oh, it is. So this is the new max. Okay. What about Great Britain now? Is Great Britain less than the lowest country score? It's not. Is it greater than the highest country score? No, it's not. So we don't do anything with that. You keep going. You can automatically, from just that alone, find out what the lowest and highest country is. And that is seriously just using conditional statements. So, are there any questions about that? Okay. How about we take a look at some of them then? And in doing so, I'm going to show you all something new, or not something new, a different way to look at some of this. So first, I'm gonna show you first, and then we'll go back the other way. So let's do this. So our user, we're gonna get information from our user. So there's so many ways to do this. So I think how I want to do this. Trying to score maybe. Actually, I don't even need that. Yeah, I'm not even gonna do it. I'm just gonna ask from the user's input. Score equals, let's see, input, and then this should actually be a float, right? Because they're gonna be float values. Input, enter, forgot what I said here. Let me see if I can go back. I didn't give of course I didn't. Enter the judge's score from China. Here the judge's score from China. All right. I'm actually gonna copy this. We already know that we're gonna have to do this a couple times, so paste this. Okay, so I got China, France, then another country. What is it for Germany? Great Britain. Sweden. The United States and Zimbabwe. All right, so we're getting all these different things from the user. We're getting these different scores. So if I want to, I could save these as different names, right? We could save this as China score, France score. You know what? I'm super lazy. I'm not even gonna do that. I'm just gonna put score 1, 2. I'm gonna put score, and I'm gonna put score 1, score 2, score 3, score 4, score 5, score 6, because I am very lazy about this. So, but so as we get each of those scores, there are a couple of things we want to do. So off the bat, if I only had one country enter something, I already know what my low country would be, and I already know what my low score would be, right? And I also know what my max would be in my my max country and my max score. So what I'm going to do here is I'm going to set low country. So I don't want to type that much, and I'm going to set low score. So my low country in the beginning is going to be China. And my low score in the beginning is going to be whatever the score was that I just got from China. My high country is also going to be China at this point. And my high score is also going to be China at this point, because I only have one thing, right? Okay. Next thing that occurs is that we get to France. France enters a score. Well, is France higher or lower than China? Well, we need to check to see. So how can I check to see? I can do an if statement. Plain and simple. So if new score, so score 1, the one that comes from France. If I want to see if it's lower than China, I just need to see if it's less than, or not lower than China, but lower than the lowest score. See if it's less than the low score. If it is, low score now equals score 1. Okay. Oops. And low C would now equal France. If it's not, we don't want to touch the low stuff, do we? Right. So if low score is if France is actually lower than the low score, we want to change France to be the new low score. If it's not, we don't want to do anything with that. But the next thing that we can check is at the max. Now, couple things you could do here. You could do 2 if statements, so make it check each time. Some people would probably choose an elif here. Some people would do an else and then do a conditional inside of that. Honestly, it's completely up to you what you want to do in that regard. I personally would probably do another if statement here, because in my mind, I'm checking a different type of condition. So they aren't directly related to one another. So now I'm going to check if score 1 is greater than high score. And if it is, I'm going to do high score is now going to be score 1. And the high country is now going to be France. Okay. Otherwise, it's staying the same. Right? Are there any questions so far about what I just did here? Okay. So now that that's set up, what am I going to do for the rest of these guys? Well, I'm going to test the same thing, right? I'm going to see if maybe what Germany brought in, is it less than the low score? If it is, I'm going to make that a new low score. Is it higher than the high score? If it is, I'm going to get a new high score. So instead of me copying, instead of me just typing this over and over again, I'm going to copy and paste. Some of you may be saying, but didn't you just tell us that if we repeat something over again, we use a for loop? I did. And this is actually the way you should be doing this. You should be doing this within a loop of some kind. But because I really want to drive home the reason why you want to do so. because this stuff isn't changing, right? It stays the same throughout. So let's see where are we at here. Got your initial France. Now we're at Germany. So that scored 2, right? So I'm going to change this to a 2. I'm going to change that to a 2, and now we're in Germany. I'm going to change that to a 2. I'm going to change that to a 2. I'm going to change that to a 2. And like I said, we're in Germany. That's 3. Change that to a 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 3. 10. And I keep going from there. Okay. Oh, I think he gave me the wrong thing. Sorry, my battery is low on my computer, so now I'm putting in plugging it in. But remember, I just got my computer back from school, and I think they gave me the wrong charger. That's what I just realized. So give me a moment. I have an extra somewhere that just happens to be the same type, but it's mine actually. Is this gonna work or not? Okay, cool. It is. All right. Okay, so we're back in business. But you all probably can realize now why I mentioned not to, why it's important to just do this stuff in a loop at the point where you realize you're doing the same thing over and over again. As you can see, we are doing the same thing over and over again. Y'all catch me if I miss something too. I'm going through these score changes and country changes as quickly as I can. Yeah. Okay. Last one. Hopefully we got them all. Is there an editor where you can find and replace code? Yes, there are a ton of different editors out there. There are different ones, like Visual Studios is one. I mean, you could honestly just use text editor if you want to. You could use Notepad++, Notepad, but Notepad++ probably a better version because then you could tell it what code you're working in, and it usually will recognize keywords. There are lots of different ones that you can download. There are a lot available online too that work well. So, yeah, there's some that work so well, like you could actually like click on this guy here and be like, okay, I'm changing all the occurrences of this at one time, and it'll allow you to change them all. So when I took Python the first time, God, it's a long time ago now, but over a decade ago, we didn't have, there probably were some available. It just wasn't something that was known. Like my instructors use Python shell just like we did. They want to do things quickly. They would literally just have it in their own text editor, so they could do control F to find stuff however they want it. so yeah, but okay. Oop, I forgot one. Zimbabwe. Okay. So now that I did all of that, I'm gonna say this. We're in week 6, I believe. Should be testing All right, so that's asking for those different scores, and let's see, what were they? Come on. Oops. All right. Okay. China, sorry, 7.7. France, 7.5. Ah, I messed up. I forgot to actually print stuff out now. 8.1. US is 7.4. That's 7.6. Okay, cool. So everything's going in nice and fine, but we did forget to print out the information. So I'm gonna print the low country. I'm gonna put a colon and I'm gonna put its score. And I'm gonna do the same thing for high country. I'll put a colon and I'm gonna put its score. Just so we can have a sense of what is actually occurring. Okay, so again, 7.7, 7.5, 7.9, 7.8, 8.1, 7.4, 7.6. Okay, cool. So it says we get United States 7.1, we get Sweden 8.1. So notice that it got the lowest and highest. And all it did, all of this was exactly what I showed you on the pseudocode. Literally going in and say, hey, is the value that I currently have set to the lowest? Is it truly the lowest after this thing was entered? Okay, if it isn't, is it the highest? Okay, let's go to the next one. Is this the lowest? Is this the highest? Let me go to the next one. Is it still the lowest or something new now? Or is it the highest? And you keep going. This is literally pretty much almost hard coding it completely all the way. Okay. So this is at the bare minimum, this is the way you should be thinking about this. Like I said, how Ryan took a step further of, hey, we see that this is the same thing over and over again, right? There's nothing changing here, except for the value that we're on, which we're getting from the float here, and the country that we're on. So, like for instance, like he said, what if I just had a list of countries? Okay, cool. And I just did this as a loop because it's doing the same thing over and over again. So yeah, we could maybe set the initial one to get China stuff and then put everyone else in a loop, let it go through the loop, and each time just test. Is the new value you gave me the lowest or the highest now? Is the new value you gave me the lowest or the highest now? Is the new value you gave me the lowest or highest now? You can do all of that within the loop every single time. All right, cool. So that gives us that, but that gave us the highest and lowest, but that did not tell us the average, right? So the question may be now, how do you find the average? Anyone know how to find an average period? Not even the fact of like that we only want the middle five or anything. Anyone know how to find an average? Okay. All right, and yes, we would take the sum of the scores and we would divide by 7. In this case, we have 7 items. That's true. All right. So to take an average, you find the sum of your values, and then you divide by however many you have. Right. Every single time. We actually know how many they will be because I told you all this is set in stone. 5 remaining. Right. So we just need to know what 5 numbers to take the sum of. So as you go down through it, at the end, we just saw, right? At the end of it, we know exactly what the lowest and highest are. So why not just take the sum of the entire thing, what could you do now if you have the sum of all 7 of them? What could you do knowing what the highest and lowest are to get to the sum of just those middle 5? Anyone got any ideas of what you could do there? So let's just say I knew the total of all 7 of them. Anyone have any ideas on how I could use the fact that we know what the lowest and highest scores are in order to find what the middle 5? So someone's mentioned me privately and said you could just subtract the lowest and the highest from that total and then divide to get the average. That is exactly all that you would need to do. That is great. So if you could somehow figure out how to take the total of these guys as you go parse through each judge, if you could somehow get the total there, then subtract off what the lowest and the highest are, you would have 5 scores. You would know the 5 middle scores, the sum of the 5 middle scores. If you have the sum of the 5 middle scores, now all you need to do now is just divide by 5, and you automatically get the average. Okay, so just another way to think about it. For that, any questions about that assignment? All right, cool. All right, what about the roulette wheel? Anyone have any questions with the roulette wheel? Anyone have any issues with it? Pretty straightforward. Okay, cool. Good. I like to hear that. So, well, I did want to show you all something with what I just did here. So let me do it this way. What happened? There we go. Oh, I went to the wrong button. Okay, so there is another way to do conditionals, to do conditional statements. And it's known as ternary conditionals. And the purpose of it is it looks a lot simpler, and it is all about evaluating something to be true or false. That's it. So if you only have 2 options, like either this works or it doesn't, then a tertiary is a good way to go. So I'm mentioning this partly because you may find it very useful in your homework that's coming up, which we'll talk about in a moment. But just in life, period. So if you know that you're going to have an if and else statement and that's it, it actually works better to use a tertiary. So let me give you an example of one. Actually, I'll do it in the Python shell instead of what we just had up, because actually I just realized it probably won't work best that way. So the Python shell will work better to show you all what we're doing. So you know what? I'm going to do this. Okay. Now we can see. All right. So let's just imagine that A was equal to the number 2 and that B was equal to the number 3. Okay. And let's say we want this thing to print greater than if B is greater than A. Else less than. Let's see again. Oh, it said it's greater than. This is probably more close. This is probably closer to the way your brain would actually think about this. So I want this to happen if this is true. Otherwise, I want this to happen. So it said greater than if B was greater than A, which it is. Okay. So I'm gonna copy that. But this time I'm gonna switch it around. Greater than B. Okay. So greater than if A is greater than B, else put less than. Let's see what it says. Less than. So this is called a ternary conditional. So this allows you to put this all on one line. It makes it a lot simpler to read and to visualize, and it's actually faster for the computer to compute this as well. A lot of times people will use this when they're assigning a variable. For instance, like what we had earlier with the scores. So actually, I will go bring that up now. Oops. So up here, we're trying to test to see if trying to test to see if the new score that just came in is less than the low score, and if it is, we want to save it as a new low score. So I could say score, or I could say low score equals score 1 if score 1 is less than low score, else I just put low score. So low score will equal the new score 1 if it's less than the current low score, else just leave it the same as low score. And that would replace this completely. Okay. I can even put a tertiary in there and say comma low C. We looked at tertiary before. That's how you can one way to use a not tertiary, sorry, tuple. One way you can use a tuple is to assign multiple variables at one time. So I could say it equals score, comma, France. And now this is all on one line. And I could leave this one as whatever the low country is. Okay. And that will replace this entire thing right here. So this one line now replaces this, and it's actually faster for the computer to calculate. So this is why tertiaries become very important. Okay. Do you have to use them? No, totally not. It's just like the F format stuff, right? I showed you F format. It's newer. It's easier to manipulate and use, right? It's faster for the computer. Just put an F in front, letting you know, hey, this is going to be a string I want you to format. But do you have to use it? No. Some of you have used the format function, used it at the end of the string by dot format. Some of you have used the modulus to replace, which again is fine. Like I said, it was the very first method that was available to us when I learned Python more than a decade ago. It is not the best method as of like a couple of years ago, and then it definitely isn't anymore because there's an even faster method than the one they used to replace it. So there's a lot that you can do that's different, but you have to decide what's going to be best for you and what you understand. So anyway, this is a ternary conditional. Again, it's the same as the conditional statement, except you don't have to have the conditional statement with a colon and then code blocks within each one. It puts it all on one line. This should only be used if you have an if-else statement. This works great for setting things equal for assigning variables. But as you can see, you can use it without that. Just to like, if I wanted to print something, I could put print greater than if da 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 da. And so it would decide what to print. Okay. So, do I have any questions from anyone about the ternary conditional? Yes. So I'm gonna give you guys a cool statement, or something that might be useful. So, I'm gonna tell it to print yes if true, else no. Oh, I want to actually do that differently. Oh well, I forgot my string. So what this did was it does whatever this value is. So this is kind of like another way you can think of this is yeah, value if true, and then an if statement, and then some type of condition to check for. So I can put true here, or it could be something else like is 7 less than 9, or whatever I want the test. Earlier I did like A and B, right? I could say if A, yeah. So if B mod A is equal to 1, this will be the value of true. Else, oh, I forgot to put it in there. There we go. Yeah. Else, this is my value if false. It says, hey, that's true. We'll change it up a little bit. If it equals the letter A. Oh, how do I just keep doing that? All right. All right, if it equals like the letter A, that's false. Right? Because B is 3 and A is 2. So 2 mod A, what's the remainder when you do 3 divided by 2? You get 1. So the first time is 1 equal to 1. It is. So therefore, this will give me value of true. Here is 1 equal to A. It is not. Therefore, it gives me value is false. So that's how a ternary statement works. You give it what's the value if true, then you give it the if conditional to check, followed by the word else, and then what do you want to occur if it does get to else? Right? What value do you want to give it if it's else? And that will be everything. What ternary statement. The whole point is again is to replace if statements when you have an if else statement. It'll be very powerful and make it a lot easier to do. Any other questions, or do you guys want to see another example of it? It's pretty much we can keep making examples just so that you can get this in your mind. Can you use an elif after this statement? No, you cannot. Some people do combination ones within. So let's see. Actually, I'm gonna give it a number. I'm gonna say, hey, I want this to be 0 if B is equal to A, else else, let's see, 1 if B is less than A, else 2. So this is how you could get away with an elif. Because remember I told you elif stands for else if. So you're still doing an if and else. But now you are, if you want to have an elif in this, this is where your elif will come into place. It's saying if this works, do 0. Otherwise, let's go to the next thing. Else, the first thing it says is it's going to be 1 if b is less than a. So that's really your elif statement. Else, it's going to be 2. And so this return 2 because b is neither equal to a nor is it less than a. It's greater than a. So that's how you could use it in use an elif, quote unquote. It would still have to follow after that else, but it would then become your first value of true. It's kind of a nested ternary conditional statement. All right. Questions? Any other questions? All right. So if you ever have something that has a ton of different commands to do, you don't want to use a ternary conditional. You just want to use a standard if statement, unless you can truly stack it into one thing. What types of statements are there? Let's see. I believe you're just like in terms of. So you have your loops, and then you have some conditional statements, and then you just have your declaration statements. So declaration meaning you're doing something on that point. Your conditional would be you're doing stuff based off a condition. Honestly, that's really it. There are other types of statements, but not really when you're talking coding. So that even those names come from actually come from English. Um, so I've been told that the English words come from the math ones, actually, the logic ones. So. But so there's like conditional statements, there's contrapositive, there's converse, and then there's like your declarative statements, and your inverse statements. But code-wise, we will only look at the well, actually, all those other ones I mentioned after the declarative are all actually conditional statements. So you just have your declarative and your conditional statements. But yeah, that is actually more of an English term. You're like, if you don't have an if-then statement, like when you speak, it's just like a declarative. Well, I guess there's other ones. You have your imperative or declarative. You have the one that's interrogative. But coding-wise, we're just going to look at the declarations and then conditionals. Yeah. Some of the things you'll declare would be for it to do a loop. You're telling it to do this loop. As we saw within loops, some of our loops have conditional statements, right? Like our while loop has a condition that you have to test in order to see if you can execute the rest of the code block. But a for loop, you just tell it straight up, hey, go do this for this many times. Okay. So that's really it. We just saw that we had conditional statements, and then we could write it differently as a ternary, just like with our for loop, we have a while loop, or we can have a for loop. We don't need if we know exactly how many items we need, or how many times we needed to run. There's something else I was going to show you all on last week with lists. What I was going to show, which I am going to show you next, but before we do that, I just kind of want to see if anyone had any other questions about ternary conditionals. Okay. So, ooh, headache. Okay. So for some other things that you can do with the list. So what I wanted to show you all was with the list, you could build a list of terms and conditions. So what this was called ternary conditionals. Yes. So So with a list, you can actually build a list as you go. And a lot of times people will do this. Will do this whenever they want to like create a variable that's going to hold a list of items. So I'll give you an example. Let's say we wanted to get all the letters in the word Christopher. We could do that. So I'm just going to call this letters equal to. And so, like in Rodney's example earlier, he did something where he used a for loop to build a list, and he appended each item onto the list as he got it. Well, you could do something similar to that in one line of code without having to build a for loop for it. And this is called a list comprehension. And so a list comprehension, the whole point of it is for you to understand or to create a list based off of some understanding. So it's comprehending. It's comprehending how to build itself. So for example, this. So if I start off with, I'm gonna have a list that's for letters. Letters is going to be equal to, it's going to equal to, I'll call it X for X in Christopher. Okay. So I can make this make more sense. Probably I could probably call this letters, and then instead of X, call it letter. Actually, I'll do that because that'll probably make more sense to many of you. Okay, so this kind of looks like a for loop does, except what I'm doing is I'm using the for and the in to build each element of this whole list. So the list is going to be letters, but it's going each element in letters is going to be a letter for letter in Christopher. So if I were to enter here, I did letters, you would expect to see a list of those letters. Notice that is exactly what you see here. Right? And so this can be another very powerful tool whenever you are working with a list. Honestly, I use this more than I do for loops because, as you can see, many times when you use a for loop or you want to do something with a for loop, you need to do things multiple times, and sometimes you need to save those values. Well, this allows me to save those values without having to actually write a for loop to do so. And it's actually easier on the computer. Again, easier on the computer to do in this way. And there are times where I want to use a list comprehension, but I need to do so many things, it doesn't make sense for me to do that. It makes more sense for me to just write a for loop. Same thing like what we did with the ternary. Like if you did an L, like what Rodney asked about, can you do elif in it? And I showed how you guys could, but you're pretty much writing another one inside of the else part of the ternary conditional. In this case, I would tell you probably professionally, just go write an if state or go write a conditional statement has if and else and elif. That's what I would tell you to do. Because even though, yeah, this looks cool, you got it all in one line, at that point, it might be taken away from any time you may be saving for the computer. And also may be harder for you as someone that was to review it to understand what's actually happening. Especially if you have a ton of, can you imagine if you had a ton of these? It would be a lot cleaner to understand and look at and to make changes later if you had it just as if and elif and else statements. So same thing with this. If I needed to do like, maybe I needed to take each of these and do some kind of weird calculation with it and then add it to a bunch of different lists, it may be easier for me to do this instead. Sorry, maybe easier for me to just have a for loop. So, but I could do things to that as well. So I'm gonna pretty much create the same thing, but this time I'm gonna take each value and I'm gonna do something to it. I'm gonna make it uppercase. And this time I'll use Rodney's name. All right. So letters is going to be a full list, right, of each letter dot upper for letter in Rodney. And so this dot upper, something else that I want to share with you guys today, but this dot upper is in regards to a method that you can use on a string. There are a couple of different ways that you can manipulate strings, and we're gonna look at a lot of those this week and next, just to really kind of hit those in, get those home, get them in your mind and your heart. But as you see here, there's a dot upper. You probably could realize there's a dot lower. I think actually we have actually I've kind of like thrown these in every once in a while, but we're gonna actually look at using the different types of things you can do with the string. But there's dot upper, dot lower, but this will make it uppercase for each letter. So what I'm gonna do now, run that, and now we get RODENEY, all capital letters. Okay, and so what you do here, you could have some calculation occur here. As long as you're not trying to save it to anything else, this will build a list for it. Okay, so it can make building a list very fast without having to use a for loop to do so. It can also make it easier to gather information from say you already use a for loop that create this huge list. You can then use for, remember this is a dummy variable, and remember this last part is just some list over here. Some of you may remember how I was trying to, at one point, I was trying to use the range function, which gives you a sequence of numbers. And what I was trying to do was, I was trying to get those numbers out. So I was like, oh, okay, let me get the 0th index of this. And it tells me 0. But as I began to try to manipulate these more, it wouldn't allow me to make certain changes. So one thing you could do, if I wanted to get all of those numbers, what I could do is I could say num equals, I'm gonna create a list of even numbers from the first 10 even numbers. So to do that, I could use the range function and just say take take n times 2 for each 10 that is in range of 10 numbers. And it should get me the n times 2 is saying get this n value. So the first time it goes through, it's going to get 0. 0 times 2 will give me 0. Next time it goes through, it'll be 1. 1 times 2 is 2. Then it goes through, n is 2. This gives me 4. So it's going to get 0, 2, 4, 6, 8, 10. It's going to keep going until it gets 10 numbers. All right, so I can build this list very quickly, just like this. So it gets me the first 10 even numbers. There's a quick way of doing that. Okay. Any questions there? There's always comprehension. Something to recall from last week that I mentioned was there were some other list functions that you could do. One was a copy function. And I showed you guys the reason why you would want to have a copy function. So I'm going to call it num2. And I'm going to set this equal to num.copy. And I'm going to set another one. I'll call it num1 and set it equal to num. And we're just going to take a look at a couple of things that occur. So num is 0 through 18 in order, going up by 2s, right? Num1 is also the exact same thing. Num2 is also the same thing. Okay? So at first glance, it looks like I didn't really do anything, right? There's no difference between num1 and num2. Now let's make a change to num, and let's see what happens to num1 and 2 when I do so. Remember that num1 is set equal to num, and that num2 is set equal to num.copy. So it was a copy of num. Yes, I know we did this last week, but I want to reiterate it again. So let's say I make a change. Let's say I say num, say num7 So I'm looking at the 7th index in num. That would be the 8th thing. So 1, 2, 3, 4, 5, 6. So it'll be this 14. I'm going to set it equal to 7. So now when I look at num, notice that that's 7 now. When I look at num1, this is also 7. When I look at num2, this is 14. When you do a dot copy, it literally makes a new version of that object that you created. So this is now equal to a copy of what num1 was, or sorry, what num was. When you just assign the object to a new variable, that means both of these variables, num and num1, point to the same object. So both of these point to this guy here. Num2 does not point to this. It points to a copy of this. When we made a modification to num, what happened to num1? It also got modified because they both point to the same object. Num2 is still pointing to the copy of the original object. It never pointed to the original object. It pointed to a copy of it. Okay, this can be very important. Another function that may be very useful to you all that are doing when you do the palindrome assignment, which is also part of your homework this week. Num dot re-up. So we get a list of. So actually, this is kind of cool. That didn't pop up before for me earlier, maybe because I was too impatient. I was going too fast. But when I just pressed the dot, it automatically said, "Hey, this is a list," and it's giving me a list of the methods that can be used on a list. Okay. What I want to show you guys was this reverse one though. So num dot reverse. What do you guys think that's going to do? What do you think reverse is going to do? It's going to put the numbers backwards. Reverse the order of the printed list. Yes. So I'm going to do that. Descending order. In this case, it would be descending. So, and it's descending order based off the index. So when I do that and I do num now, those, as you all thought it would, is going in reverse order that was printed. The numbers are backwards. It's in descending order from the index. So now 18 is now the 0th index. And so now 18 is now the 0th index when it was the 9th index before. And so everything I make. So notice that when we do sort and reverse, it automatically changes that actual object. So sometimes you may want to be careful about that, right? Like we saw earlier with the example where Rodney was doing it. If you just change the order at any point in time, you may want to do things later on, or you may want to do things with that before you make that change. You may want to make the change and have what it originally looked like at the same time. If you do, you want to do a copy of it so that you have both versions. So you can do a copy of it so you have the original version saved somewhere, and then you can manipulate the other. Okay. By the way, your palindrome assignment, in case you don't know what palindrome is, this is a palindrome. Oops. Mom is a palindrome because it's the same forward as it is backwards. We'll be using this technique this week, you say. Yeah, I suggest you do. Race car is another one. Someone just put in the chat, race car. If you notice that if you look at this forward and backwards, it's the same. You don't have to use this coming up, no, for this week's assignments. It could be very helpful. One of your assignments is to check to see if you have a palindrome. So this is something that would be very useful to you, most likely, if you're trying to check to see if you do have a palindrome. Right? If it's the same forward as it is backwards, then it works. Right? So, speaking of your homework for this week, take a look and see. It should go to the video. Yeah, it does. On binary, decimal, and hexadecimal. All right. Someone in the chat said that the palindrome sounds like it's going to be a difficult assignment. Let me ask you all this. So what I just showed you with the with that reverse function, if you somehow were able to put your string in a list and you compared it to, somehow you were able to compare it to how it looked backwards, would you be able to see if it was the same or not? Ah, okay. I got some O's and ahas in the chat. So yeah. So think about that. If you need to check to see if something's a palindrome, all you're doing is seeing are the strings the same forward and backwards? Have you seen a way so that if you have a string that you can put it into a list? Have you seen a way to take a list and see what it is reverse? Have you seen a way to maybe check to see if it is the same as it originally was? This is just one way. You don't even have to do that. There are tons of different ways. You all have seen how to look at a string to get the index of a string backwards too, or of a string. So kind of refresh you. I don't know why it's looking like that. I can't see everything, but kind of refresh you on that. So let's say S was some string like call it race car, because we just did that earlier. I can know what's in race car from say 0 to halfway. Ugh, did not like that. Must be integers. Okay, I know what happened. The only way to guarantee that when I divide the number, it's going to be integer is if I use integer division. So I said go about halfway. So it did. It went from 0 up to, because halfway, how many letters was in this? 7. So 7 divided by 2, integer division would give us 3. So it went from 0 to up to 3. So about halfway is at race, right? I could do that. Some other things that you all saw that you could do was you could look at things backwards using -1, for instance. That returns stuff backwards. If you don't believe me that it does, let's just do a different S. I'll call it Christopher. And if I want to look at this from the last index backwards, so I use a -1, puts it backwards for me. That's how you can do it on a string directly. You don't even have to change it to a list first to do so. Perfectly honest with you, the palindrome assignment could take you 1 line of code to do. Well, after you do all of the put your title, your name, your description of what your assignment is, you could honestly do the palindrome assignment in 1 line of code. So I suggest actually, once you get done with your homework, just, do your homework, then go back and see if you can put it in 1 line of code. So, yeah. All right. You guys will have fun with it. So let's look at this assignment though first. This one's going to be the one that takes a little longer. You may have noticed that usually the first one takes a little longer. The second one usually seems pretty straightforward, right? I hope that all are straightforward, but so okay. So what you're going to do is you're going to convert from binary to decimal, hexadecimal. You're going to be doing some conversions between them. So what's very important to know here is how to actually do this, because if you don't know how to do this, like the actual conversion, if you don't know how to actually convert from binary to decimal, or from decimal to binary, or from decimal to hexadecimal, or for hexadecimal to decimal, then this assignment will not mean anything to you. And you'll be frustrated thinking that you can't code, which won't be the case. It's just maybe you don't understand how to make these conversions. So that's what we're going to look at first and foremost. How do you make those conversions from binary to decimal, decimal to binary, and decimal to hexadecimal, hexadecimal to decimal. So let's see what these actually are. And I'm going to show you with a calculator. So just the in program calculator. I'm going to change this from standard to programmer. Notice that we get these different bins. That we get bin, which stands for binary, oct, which stands for octal, decimal. Notice that it's blue right now, it's highlighted, and then hexadecimal. So what does that mean? Each of these is a different representation of a number in a different base. So traditionally, whenever you think of counting numbers and doing math with them, you all are thinking in base 10, which is known as decimal, right? So that makes sense, right? Every number that you ever deal with has a decimal, even if it's 0.0 at the end there, there's still a decimal that's occurring. Another reason that it's called decimal is because that stands for, like I said, base 10, because we deal with things in base 10. We deal with things in tens, right? So just think about it. Look at your place values. They start at 1, then it goes tens, then it goes hundreds, which is 10 times 10. Then it goes thousands, which is 10 times 10 times 10. Then it goes 10,000, which is 10 times 10 times 10 times 10. And it keeps going, and everything is based off tens. Well, let's say you didn't base things off 10. Let's say we base things off of 2. That means our first, yes, like deca equals 10, yes. So that means our if we base things off of 2, that means our ones place would still be the same, it'd be 1. But instead of a tens place, we would have a twos place. Instead of a hundreds place, we would have a 2 times 2's place, which would be a 4's place. Instead of a thousands place, we would have a 2 times 2 times 2, or an eighths place. So each time we do a base change, we just look at what is the base that we're basing things off of, in this case, base 2. And then from there, our place values increase. So they always start at whatever the 0th power is. Yes, yes, 2 is 0, which is 1. Then they go to the next value, so it'll be to the first power, which in this case would be 2. Then they would go to the next power, which is 2 to the second power, so that would be 4. Then we go to the next power, 3, so that would be 8. And it would keep going. So 16 and 32, 64, and so on and so forth. Okay. So, right there, I don't want to do that. And okay, cool. So, what I want to do here, ooh, that was cool. So, what I want to do here is I'm going to type in a number. So, let's do 255. Notice here, when I type in that number, what happens here? It gives me what that would be in hexadecimal. It gives me what that is in decimal. It gives me what that is in octal. And then it gives me what that is in binary. Yes. So pretty much what you all are going to be programming is for these calculations to take place. Your user will choose A, B, C, or D in order to convert from decimal to binary, binary to decimal, decimal to hexadecimal, or hexadecimal to decimal. Once they make that selection, you will ask them to enter in a value. And the value they enter in, you will then convert based off what was selected. So if they chose to go from decimal to binary, that means what they give you should be a decimal number. So it's a number between 0 and 255. And then you will, you'll give you a decimal number 0 to 255. And then after that, it'll spit out a binary number. So you want to give them the binary value. Okay. If they ask to go from binary to decimal, you are expecting them to give you a binary number from 0 up to 8 ones, as you all see here. And actually, I think I told you all in your instruction. Let me pull it back up. It's right here. Yeah, there should be 8 digits they give you even. So they should give you the 8 digits because I made this a little easier then. Yeah. So they should give you 8 digits. So they give you 8 zeros or they give you 8 ones. And so you want to check to make sure the length they give you is 8. You also want to make sure they're only zeros and ones. Right? Because if it's not, then you want to probably tell them they entered the wrong number. Just like up here, if they gave you a number outside of the range of 0 to 255, you probably want to tell them, hey, you gave me the wrong number. Converting from decimal to hexadecimal, same thing. You want to get a number from 0 to 255, and you want to return a number from between 0, 0 or FF. Hexadecimal, so that you know, hexadecimal goes from is 16 base or base 16. So I want you to think about the first 16 digits that you know. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then Ama, Baba, Gupta, Gupta, Ike, Bafat. Right? You guys know those, right? Those last ones I just mentioned there, you know those, right? No, you probably don't because I just made those up. But we need a base 16. And so what we have done is we have equated for base 16, we've equated the value of 10 to the letter A, 11 to the letter B, and these are our capital letters, sorry. Capital A, capital B. For 12 is capital C. For 13, capital D. For 14, capital E, and for 15, capital F. Okay. And so what does that mean? That means this first base value is 16 to the 0th power, so that's 1. And then this, that's 1, the ones place. This would be the 16th place, which means that this is 16 to the first power. This is how many that you have. Okay? So in our case, we have a 15 here. So 15, 15 will be the same as 255. 0, 0 will still be 0. Going hexadecimal to decimal is the other direction. You would expect for them to give you 2 digits, which would be between 0, 0 and FF. And then you would convert it to the decimal equivalent. So a lot of you may be asking, how are you supposed to do this? You can do this all with just conditional statements. You don't have to use a single list. You can if you want to. Again, it is completely unnecessary to do so. So let's take well, before we do that, I'm gonna look at the next one. So yeah, let's look at this. So yeah, printer description stuff. You will use a nested if or elif step structures. The outer if and elif will be the operation the user chooses A, B, C, or D, as well as else that should catch any other user choice and provide an error message. Then inside each operation fork, you will likely utilize one or more if else or if elif. So what that says there is that you want to be able to, first of all, make sure that the user chooses A, B, C, or D, right? What if they write it in lowercase? Is there a way for you to make sure that whatever they give you is an uppercase value if you're only checking for uppercase values? Yes, remember that dot upper we talked about? And is there a way for you to check to make sure they gave you A, B, C, or D? Yeah. You can just check to see if the string they gave you is equal to, remember double equals, because it's conditional, if it's equal to A, or if it's equal to B, C, or D. And if it's not, you could give them a print statement that says, hey, you didn't enter in the correct number. Rerun the program and start over again. You know, however you want to do it. Let's see. Inside each operation, we're also going to check to make sure that the correct range is used. So we want to make sure the right number is used in between them. As I gave you up here, right? So she goes 0 to 255 if it's a decimal. it should be 8 digits like this. If it is a binary value going decimal, it should be 00 to FF, so it should be 2 digits if it's a hexadecimal. So I said you use ternary conditionals if you want to within this. There are some built-in functions that will do some conversions for you. So for instance, okay, so binary, so BIN, so binary of let's do 127. Notice what it gives you here. So the binary value for 127 should actually be 7 ones. Yeah. So the way it gives this out to you is a string that starts off with 0B to let you know that this is a binary number, and then everything that follows is the actual binary number. So this 127 to binary is actually just this last part of this string. Everything that follows after that B. Okay. And no matter what you do, what number you do, oh crap! I just actually added a bunch of stuff I didn't need. No matter what number you do, it will always start off with that 0B. So if you need to convert binary, if you need to convert decimal to binary very easily, this could possibly be some trick that you use, this function bin, because it will literally give you what it is as a string right here. Except for the only thing that you would have to get rid of somehow magically would be these first 2 characters within this string. And remember, strings are really lists. If only there was some way that you knew of to get rid of some characters within a string or a list. Okay. There is likewise another function called hex, which does hexadecimal from decimal. So if I put in 25, it gives me 19. Okay. So let's see if that makes sense. Remember I told you hexadecimal was base 16. So this 9 is in the ones place. This 1 is in the 16's place. If I have 116 plus 9 ones, that's 25, right? 16 plus 9 is 25, so this works. And once again, you could use any value you wanted. So let's say we did do 255 here. Notice we get FF. Notice that the difference between these two, binary had the 0B, hex has 0x. So if you wanted to use these functions, it is not required. It may make it helpful for you because that takes care of half the work you have to do for your assignment. Again, you don't have to use these. But if you do want to use them, keep in mind that the requirements say that you should have capital letters. This gives you lowercase. If only there was some way to make a string into uppercase, some method maybe that you have seen, dot upper, that will do that for you. Okay. So, all right. So we have about 27 minutes left. I decided that I wanted to end today based off of asking you all, which one do you possibly want help doing? The conversion from binary to decimal, or the conversion from hexadecimal? Oh, sorry, yeah, from hexadecimal to decimal. But before that, are there any questions about this assignment? Anyone? No? Okay. All right. In that case, there are lots of different choices, examples for you guys to practice with too. Go forward here. So look at the Palindrome tester. So this assignment provides practice with repetition structures, the use of a for loop. Honestly, it's not even necessary to use a for loop for this, but just anyway. So the whole point is for the user will enter in a word, phrase, sentence, or number. You will return if it is a palindrome. Okay. So the user should be prompted to enter a word, phrase, sentence, or a number into an input string. I'm sure you all are fine with that at this point. It says to use a repetition or a loop in order to go through each letter of the input. So even gives you a little thing there. While that's supposed to be while a loop through, will loop through each character of the myString variable. You can then examine the characters in a conditional structure to determine if the character is a letter or a number. Concatenate it to two strings, one forwards and one backwards, which you guys know about now, while removing the case sensitivity, maybe an upper or lower. Then you can compare the two strings to determine if they are equivalent and report out the print accordingly. So one thing to note here is that when the phrase is entered, the so Madame, I'm Adam is not a palindrome. Madam, I'm Adam is considered a palindrome because it's not taking into account the what is this called? The punctuation. Okay. So if you were to use this, you may want to think about carefully how would you want to test this without to make sure it didn't use the punctuation. Is there a way to do that? And there is definitely a way to do that. So I want you guys to, at this point in time, I would worry about trying to make sure these first two cases work. Bob and the 1, 2, 3, 4, 3, 2, 1. These, if your code can work for these, then I'm gonna get credit for it, and I'm gonna talk more about how you could manipulate this within the next 2 weeks. So feel free to ask me about it in office hours though, about how you could get rid of the punctuations and not worry about using them. But I mainly want to see that you all can understand how to take a string, maybe modify it a certain way so that this would be true, even though this is a capital letter and this is a lowercase b, but these are still the same letter. And to tell it to ignore, that's what I'm more focused on. The fact that you will be able to tell it to not worry about the cases, which you may want to decide to use some kind of function, like I mentioned here, to remove that, maybe make it everything uppercase or make everything lowercase when you're doing your testing of it. But yeah, worry about these two cases first. This guy we can talk more about next week or the week after when we go through this assignment. But yeah, so I kind of already talked about earlier how simple this could really be. Like you really honestly could do this in one line, but just think about it. You're getting something from the user, and then you want to check to see what's gotten from the user once you've removed the case sensitivity. Is it the same forward as it is backwards? And I've shown you 2 ways how to do that today, and in the past couple of weeks, you've seen that a couple of times. You've seen how you can take a string directly and splice it so that you can see it backwards. You've also seen how to take a list. If you put a string, each letter in a string in a list, how to reverse a list using the dot reverse. So you have a couple of ways to test this. Okay. After that, have fun with trying to see what if it has punctuations in it? How do I tell it to ignore the punctuation? Okay. There are a couple of ways to do that. So, all right. So, any questions about your 2 homework assignments for this week? Okay. All right. In that case, let's my office hours are 4 to 5:30 Monday through Thursday. So, what would you all like to see? Would you like to see us, or like, as an example, would you like to see going from binary to decimal, or would you like to see going from hexadecimal to decimal? We got 4 votes for hexadecimal to decimal. No one else is saying anything. So, all right. Well, actually, I have 4 outvotes itself because there's 7 of y'all in here still. So, all right. That's what we'll do. We'll go to hexadecimal, from hexadecimal to decimal. Okay. Oops. And there's a video here showing it in a different language. That you may find that helpful to you as well. So that's the wrong one. Get a new file. Okay. So before we begin this, I want to talk about how you actually would convert from hexadecimal to decimal. Once you have a value, what you would then do is check to see if the number that is given is according to the instructions, right? Actually, let me go back to those instructions. That was the second one here. Okay. So what we want to do is we want to convert from a hexadecimal value to a decimal value. Okay. It says the user's going to give us which one they choose. Say they get to this part, and then they're going to enter in the value. The value should be between 0, 0 and FF. So we would want to check that. Then after we did that, we would want to begin converting. So so first things first, we're going to get the user input, right? We're going to get a value from them, which is going to be between 0, 0 and FF. Okay. Once we get the user's input, we want to test to make sure input is between 0, 0 and FF. Okay. Once we test that, we can convert. Hex to decimal. Okay. So let's start off by how do you convert from hex to decimal? So remember that the first value here, because it's only going from 0, 0 to FF, we know that it should only have 2 things, right? It should never have more than that in regards to size. Okay. So we're going to test for that stuff already before here. So we already know when we get to the point where we're converting that a value is 2 digits here between 0, 0 and FF. All right. And it's a string. So the first thing that's in the string is going to be what's in the 16s place. The second thing in the string is what's in the ones place. Does that make sense is there anyone have questions about that 16s place and that ones place that I mentioned? Any questions there? Okay. So I'm going to call it hex. So the hex is a string with 2 parts. Yes, I can explain it again. So in regular, when you have when you think of a number now, it's in decimal. Yeah, you're fine. It's in decimal. So like the number 37, it is in decimal. Okay, it's in decimal because it's based off of 10. It's base 10. What does 37 actually mean? It means you have 7 ones and 3 tens. If the number was 143, you would have 3 ones, 4 tens, and 1 100th. As you keep going up in place value, you increase the power of that base. The ones place is representative of the 0th power. The next place up will be representative of the 1st power. After that, it will be representative of the 2nd power, and so on and so forth. In our case, we're only looking at 2 things. We're looking at the ones And because we're in base 16, this becomes the 16s, because this is 16 to the 0th power, which is 1. And this is 16 to the 1st power, which is 16. So the way that this would count, you would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you would go A, B, C, D, E, F. The next thing would be 1F. B 1, 0. Then it would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1A, 1B, 1C, 1D, 1E, 1F. And then you would increase the 16th place by another one, so it'll be at 2. So it'll start at 2, 0. Just like you do with the decimal numbers that you're used to. Except instead of only having 10 digits, you now have 16. Instead of going from 0 to 9, you go from 0 to F. Okay. So does that help? Cool. Let me know if it doesn't, so that I can go through some more examples if we need to. So hex is a string with 2 parts. So A through F are 10 through 16. They are 10 through 15. But yes. So to count, yeah. So yeah, count that. A would be 10, B would be 11. Yeah. Good. Okay. Which makes sense, right? Think about decimals. We don't say that the ones place goes from 0 to 10. It goes from 0 to 9. That way we still only are using 10 digits. The number of digits will always end one less than what your base is. All right, so the hexadecimal has 2 parts to it in our case. Yep. So the 2 parts, as we said, the first part, the first part, which would be the 0th index, is the 16s. The second part, which would be index 1, is the 1s place. Okay. So all I need to do now is just check to see what number do I have. That's it. So I can convert the first part to decimal. Then I can convert the second part decimal. And then maybe I can combine those decimals together. And print out result. All right. So it's pretty straightforward. This is all I need to do. I need to get the user input, test to make sure it's between 0, 0, and FF. Convert the, now I'm going to actually do the actual conversion from hexadecimal. To do that, I'm going to realize that a hex is 2 parts. The first part, which is the 0 index, is the 16s. The second part is the 1s. Then I can convert the first part to decimal. Then I can convert the second part to decimal. After I do that, I just combine those 2 things together, and that's the whole decimal. So let's do some of this. So how am I going to get user input? Let's call it hex. Well, that's good. That's a special word, so I can't do that. I'll call it hexy, like Lexi, but she cursed me. All right, hexy. So hexy, and enter the hexadecimal value in range of 00 to FF. I made that all fancy. Could just say enter number 00 FF. Okay. Next, test to make sure that the input is between 00 and FF. All right, cool. Well, what if they accidentally type lowercase letters in here? What if they accidentally type all uppercase, but you were testing for lowercase? Remember in the code or in the project, it said to maybe get rid of some, yep, you guys, a lot of you are typing in the chat .upper. Yeah, when you're going to get rid of case sensitivity, .upper will work perfectly fine. So no matter what they enter in, I'm going to put a .upper at the end of the string that comes from input. So it will automatically be uppercase. So that way I don't have to worry about it. Okay. What if they're letters? .upper still takes care of it. It just leaves it the same. So now we're going to test to see, make sure the input is between 0 and FF. So to do that, this is a conditional statement. So I'm going to tell it to, I'll do it as actual conditional. Put these as a tertiary actually too, but so that's so hexy, if hexy is less than 0, 0, or hexy is greater than FF. I want to print you messed up. Give me, we also need a parentheses when we are putting something at the end. What's the term for that? Oh, okay. It's a method. So the question was, what's the term for why we're putting the parentheses at the end of upper here? So the reason we're putting the parentheses at the end of upper is because it's a method. So anytime you use any type of function, which we'll get more into those in a couple of, like actually many weeks, probably like 4 weeks. But when we get into functions, when you create a function, you have parentheses to denote the beginning and end of the function. So like maybe when you've done like things in Excel, you'll notice that it'll have the name of the function and the open parentheses and always puts a closing one. It's to let it know that you have you've begun this function, and that parentheses is where you put in any arguments or parameters that you'll use within the function. For example, here, look at the screen tip I get for it puts print parentheses. It tells me that it's expecting a value there, maybe some other things, and then it's assuming the separator is a space. Its end of it is going to be a new line. All of that stuff that it has there. That's what will go in within that parentheses. Okay. Sometimes the only parameter it needs is absolutely nothing. So give me value between 0, 0 and FF. Okay. Pretty simple. I told it to give me a value that's between those. If it doesn't, or sorry, if it is between those, because right here I'm testing to see, is it less than 0, 0? I'm testing to see, is it greater than FF? Because if it is, then that's a problem. Otherwise, my else, okay, what are we going to do now? We're going to convert from our hexadecimal to decimal. Actually, I probably should put that else underneath here because it'll make more sense to me. Please. Oops. All right, so it says hex is a string with two parts. Let's separate those two parts, shall we? So those two parts are the first part and the second part. So I'm gonna actually straight up do that. I'm gonna say hex 1 because I can. I'm gonna say that's equal to hexy in that 0th index. And then hex 2, second part, is gonna be hexy in the first index. And so I'm literally splitting it into those two parts, using the fact that I know the 0th index is the first part. So if it was FF, it would be this first F. And then the first index is the second part, which should be the second number that's here. Okay. All right. Well, I know that the first index is the 16s, right? So what I want to do in this case is I want to take decimal So whatever my end product is going to be, I'm just going to call it decimal because that makes sense. Could call it deci, but I'm going to take that and I'm going to set it equal to whatever this value is, right? So the easiest thing to do would be say, oh, just take whatever the value is that's in hex 1 and just make it into an integer, right? That makes sense. Right? If it's 9, then it's 9. But I would do something else with that, right? What else would you do with that? This is the 16s that we're looking at. If we're in the 16s place, let's say there was a 3 there. What would I need to do with that 3 in order to figure out the decimal equivalent? I'm gonna open this up so you guys can see what I'm talking about. So if I had 3 0 there, notice what happens to the decimal equivalent. It becomes 48. How did that happen? Remember, this is the 1s place. This is the 16s place. For every 1 in here, that's 16 added to the original decimal. So in other words, if you thought of this as 16 times 3, we would get that 48 that it got. So what I need to do once I int that hexadecimal, that first part, in order to change it to decimal? Not easy. Right? So no matter what number that we end up getting from this, what would I need to do in order to get its actual decimal value? If it's representing each part in it represents 16. We're in the 16s place. Think about when I was talking about the number 37, the 3 actually represents 30. How do I get that 30? How do I know that 3 and 37 it represents 30 in decimal? And why does the 3 in the number that we have here, the example I gave, why does that 3 represent 48 in hexadecimal? So no, we're not dividing it. It doesn't automatically equal one number. What we need to do with it? Okay. Not do it this way. All right, so in decimal, I'm going to type in the number 16. Notice what happens to hexadecimal. It becomes 1. Well, let's see. What is 16 times 2? I know that to be 32. Notice what happens to hexadecimal. This becomes a 2 now. I know that 3 of these is 48. But that becomes a 3. I know that 16 times 4 is 64. Look at this number. It becomes a 4. If I know what this number here is in the front, how could I figure out how much to add to that, how much that decimal should be worth at a minimum? What would I need to do? Add the remaining. Okay, so in hexadecimal, if I put 5 here, 50, why does this become 80? For every 1 that's in it, yes, for every 1 that's in it, it is 16, right? So how would I figure out how much that would be if I have 5 of them? If for every 1 of these, that's 16. How would I figure out how much that would be if I have 5 of them? Yes, 16 times that 5. That's how we get 80. Every single time the way we're getting this decimal part is taking that 16, because this is in the 16th place, and multiplying by this number. Same thing here. The reason you know this is 80 is because 8 times 10 is 80. That's how you know that's true. Okay, so So the value we're doing is we're taking this here, multiplying it times 16. Okay. All right. So I'm gonna tell you right now, there's an issue with this. How to do? Okay. If I told you to int the number a and multiply that times 16, it gives me an error. This could possibly be the letter A, right? Or B or C or D or E or F. That means before we do this, we need to check to see if those things are, if those are possible. So what I actually want to do is to check to see if, sorry, before I do that, I want to check to see if the value of this first part is equal to A. Put 0. If it is, what should that be? What does A represent? Run out of time. A does not equal. A does not represent. Yeah, A represents 10. That's right. So this A would be 10 times that 16. Okay. A would be 10 times 16 if the first spot was A. The class is 8:31 right now. You guys can stay on if you want. I'll keep going. So that way you all will have a full example how to get started at least with this. The binary one will probably be easier just because it's just numbers. You don't have to deal with the letter part. But. All right, so yeah, so A would represent 10 because remember you go from 0 to 9, and then you go A, B, C, D, E, F. So the decimal part would be 10 times 16 if A was A, or sorry, if the first part was A. Okay. Well, what if it's B? We can do this for each letter 3F. Yes, we can. So what? But tell me what that value would be if it was B, and if it was C, if it was E, if F. We're still looking at 10, or do we make a change here? Right. We make this 11 now, and we keep going all the way up. So, all the way up to F. So C, D, E, and F. Okay. So we got when it's 10, we got when it's 11, we got when it's 13, we got when it's 14, and we got when it's 15. All of those are taken care of. Any one of these examples. Okay. Now I could put each of these in its own thing, or sorry, all of this in one line. Could totally do that if I wanted to. You could put this into an elif conditionals. You could do that too, right? You just go if hex 1 equals A, then do this. Elif if it's B, do this. Elif if it's C, do this. Elif if it's D, do this. Elif if it's E, do this. Elif if it's F, do this. Otherwise, do this. You can also use a tertiary, and what you can do instead is we can set the decimal equal to 0 up here. With that set equal to 0, we could just say we're just going to add to it whatever we get. And so now we can make this a true if-else statement, as I did earlier here. Right? Only problem is down here, let's say it got through all these, but it was A, right? So this part already worked, but it gets down here, as we saw, we're gonna get an error with that. So I need a way to test to see if this value here is actually a number or not. And I'm going to show you how to do that here. So if hex 1, excuse me, dot is numeric. So is numeric literally tests to see if it is a number. There's another function called is alpha that checks to see if it is a letter. There are a couple other ones. There's one that's called is space. Guess what it checks? Yeah, to see if it's a space. So these are some more string methods that we'll look at in the future. This is not the only way to do this, but I figured this would be a good introduction to some more of those string manipulations that I mentioned. So right now, what this is going to do is going to increase decimal based off the number that we enter. Sorry, it's that first digit that we give it. So I want to just run this part right here just so that you all can see. So I'm going to put the last part here. I'm going to print out the result. So print the decimal. Okay. I'm going to run that. That's 6. Ooh, okay. All right, so enter my hexadecimal. I'm going to put A0. Notice that it gets 160 because A is representative of 10, like you guys told me. 10 times that would be 160, right? All right, let's run it again. So let's do B0. So we should be getting to 11, right? So it should be 176. So we get 176. Let's do another. This time, let's just do like a random letter. So I'm just going to do the number 80. So 8 times 16. So we get 128. Okay. So it's working for just that first part, right? It's working just fine. All right, so any questions about that first part for those 16s? No? All right, cool. Okay, let's look at the second part here. So for the second part, how's it going to be different from the 16s when we're looking at the ones? What's going to be a difference in our code? What's the difference in our code? We're still using A, B, C, D, E, F, and the numbers 0 through 9, but we're in the ones place. So what's the difference in our code? Where with the 16s, we did 10 times 16 if the first part was A, 11 times 16 if the first part was B, so on and so forth. What's the difference going to be? Okay. I think you all are more looking at the hexadecimal part of it. Like I think the coding part I honestly think the coding part you understand. It's the fact of not understanding how to convert the hexadecimal that may be slowing you down. I can see the possible difficulty in the fact that you've only seen, yes, someone said multiply by 1. That's the only difference that will do. Instead of multiplying by 16 or multiply times 1. That's right. So I could see the difficulty with this in that your mind's still stuck in base 10. And that's how you're thinking of everything. But as you can see, when we're looking at a change in base, all that happens is the number that you're multiplying by is different. You don't actively say like the number 98 is 9 times 10 plus 8 times 1. You don't actively say that, but that's what it is, and you understand that. Now, just instead of it being times 10 and times 1, you're doing times 16 times and then times 1. Okay? So yeah, same thing here, right? The only difference is, like you all said, we can just do times 1. Do I technically have to put times 1? I don't, but does it hurt? No, it probably make it easier for you to understand what's happening too, right? So 1 equals a else 0. You know what I'm gonna do with this? Actually, let me go this route. I'm gonna be realizing stuff here. That part, that way it's already set up for me. Just changes the just channel times 1. Okay. All right. So we just got the second part and we did the conversion for it. So honestly, this stuff should be above. Oops. What the heck? It got rid of it. Okay. Everything go away? Okay. Okay. There we go. Okay. There it is. Now it's working. All right. So same stuff, except now we're multiplying times 1 because we're in the ones place. And since we add to our result each time, that should be it. So 66 gives me 102 because 6 times 16 plus 6 more would give me 102. And if I wasn't 100% sure in that, if I didn't believe my code was working properly, what I could do here, say it's in hexadecimal, put 66. Look what happens here. It says decimal should be 102. So it's working perfectly fine. Perfectly fine. I wanted to do, I can do AF. Gave me 170. Well, remember, F is 15. A is 10, so 10 times 6. Sorry. A times 16, or 10 times 16 will give me 160. Did I forgot something in here? I did. I know I messed up. All right, this part is where I messed up. Let me go back so you guys can see that. So first thing looked like it was fine, which it was, but this next part is not, because they're different letters. So the reason it gave me a mistake is because up here, this was looking at the first one, and we're supposed to be looking at the second one, but I didn't change these guys. Confused. Okay. Let's do that now. There it is. That's right now. So A times so 10, because A is 10. 10 times times 16 is 160, plus F, which is 15, we get 175. And you could play around with a couple of different ones if you wanted to. Make sure that 10 gives you 16, so on and so forth. But as you can see, it's working fairly well now. We got everything accounted for. But we started off again with planning exactly what we needed to do. And then we move forward from there. Now, this is just one of the 4 different things it needs to be able to do, right? I showed you, though, how you can use the built-in bin function for it to calculate the binary equivalent of a decimal. I showed you how you can use the built-in hex function for it to calculate the to calculate the hexadecimal version of a decimal. And then we looked at now how we can take the hexadecimal and convert it back to a decimal. Doing the binary one might be a little easier. So, any questions for anyone? Okay. Yes, there is a way to do this through loops. It's definitely available through loops. As you can see, there's a lot of things that are repeated. So some of you may be thinking about doing that instead, which is fine. A couple of lists that you could build to take care of some things, probably to make things a little simpler for you. Yeah. Okay. Well, if no one else has any questions, I'm gonna try to see what I can find to eat that's good around here at this time. Yeah. Open to suggestions. Questions and suggestions. I'm gonna start recording. How would you like that? Okay, that's weird. Let's see. There we go.